Do 10.1.4. I will say there's a lot of, I think, valuable information in this section. This video is going to be jumping around a lot. I would say hold on to your hats, try paying attention. Again, always reach out if you have questions. Be filling out that little form, the Chapter 10 notes, and try the problems yourself before you watch me do them. Having said that, this section is really about comparing spread. Now, we know when we have something that's like normally distributed versus something with like a tail, we said that in this example, it's okay to use the mean. And this goes back to like chapter 10.1.3 parts 1 and 2. If you want to watch those videos, I think we go into a little bit more in depth there. But it's always okay to use the median. So here we can use the median. Here we can use the median. If it's skewed left or skewed right, or if there's outliers, but we shouldn't use the mean in this situation. So when we measure spread, we're going to look at another way of measuring spread today, and it's known as the standard deviation. I'm sorry, my dogs are going nuts right now. I don't know what's going on outside, so my attention's a little distracted. So anyways, if we have a normal distribution, we should use the mean. We can use the mean, and if we use the mean, the standard deviation comes straight from the mean. So again, you can use the median, but that's really not what we're going to do today in this example. If it's a normal distribution, we're okay to use the mean, and we're going to use the standard deviation to measure that spread. Or if it's a skewed data set, we're going to use the median, and that means that we should use the interquartile range, which, if you'll recall, is quartile 3 minus quartile 1 in the five-finger data or the box plot. So essentially, like I said, what we're looking at is we're looking at the data. We're going to say, oh, this data is normal. I can use the mean and calculate the standard deviation. Or this data is abnormal. It's skewed, or it's got outliers. So I'm going to use the median, which means I should use the interquartile range. Don't forget, I know it's going to be a little bit confusing, you can use this data over here as well. That's fine. But you should not use this data over here. Having said that, I hope I've done an okay job of sort of explaining where we're beginning with this. I know it can be a little bit kind of confusing, but once you get the idea behind when you can use one and not the other, we're usually okay with that. So as always, feel free to Google somebody else's much better explanation on YouTube. So 1060, a biologist is trying to determine which sugar is more successful in growing a particular eukaryotic cell. She collected the data below, the diameters in micrometers. So sugar W has these ones, and it has this checksum. Sugar P has these ones, and it has this checksum. So it says, make a combination histogram and box plot for each sugar. Use an interval of 10 to 80 with a bin width of 10. By the way, there's going to be a bunch of jumping around in this videos because I'm going to show you how to do it on the TI-84 simulator. You'll notice I already have that data for sugar W in L1 and sugar P is in L2. I'm going to show you how to do it in Desmos, and I'm also going to be using, I don't know if you guys are familiar, this is like a free version of Excel spreadsheet called LibreOffice. So I don't know how good you guys are with Excel spreadsheet, but I'm supposed to do a lot of math by hand today, and I am not gonna. I'm gonna cheat and use Excel spreadsheet, but you should be doing it by hand. The only reason I'm not doing it by hand is because it's gonna get real messy, like trying to write on this information on these pages. So long story short, they wanted to make a box and whisper plot. So I'm going to go up here. I'll make the first one for L1. I don't know if they told me. Anyways, I'll make the histogram first for L1. Now I'll go over to plot 2. I'll turn that on. And I don't know if they told me it was okay to use the one with outliers or not. I'll use the one with outliers just in case. I'll graph it. You'll notice nothing. It starts to show up right there. Obviously, all the information's over here. They did give us some instructions, though. They said to make the x intervals go from 10 to 80, and they said to use an x scale of 10. If you remember the Y scale, there aren't going to be, Y scale is like the count, how many of each appears. There's not going to be 0. And if you remember from last time, I'm going to choose like 20 to give room for my box and whisker plot. I will look at that. I get something that looks like this. At this point, again, what I would do is sort of handwrite this over with the scale on a separate piece of paper. I don't know if you guys can hear my dog, but he's distracting me. I'm sorry. So at this point, we could handwrite this. Again, we would want to write one on top and one on bottom so we can make a direct comparison. I'm going to end up doing this in Desmos anyway, so I'm not going to take the time to do that, but you should if you're using the TI-84 calculator or simulator. Again, if you're using Desmos, I'll show you how to do that in a minute. So at that, I'm going to go change this plot to L2. So this will give me my L2 histogram. I will change this plot to L2. And again, I already have my window set, so I'm going to hit graph, and you'll see I get the exact same look at it, which is kind of nice. And now I can just sort of put them on top of each other and see which goes where. All right, so what if I want to do the same thing in Desmos? If I want to do the same thing in Desmos, we're going to go here. I don't know if you guys remember, but you're just simply going to name the list L. I chose L and M. I'm assuming you can use any letters you want, but I choose L and M. So my first list is going to go here. I am going to make a histogram of M. Shoot, should I have paid attention? Okay, there we go. I kind of move my scale around. A couple things I can do. I can, again, change this bin width to 10 like it asks us to. It goes to 10 to 80. Again, I'm going to go to left on this so it looks more like what the calculator shows. You can see it just centers it about the numbers, or it goes like left of the numbers. So anyways, I have that. I will now go with the box plot. You can see Desmos makes this really easy. It's right on top of it. So again, I'm going to do an offset of like 5. I guess I'll do an offset of like 15. So you can see I have that data right there. And this time I want to do a little bit different. Last time in 10.1.3 I sort of took a screenshot and went and did something else. This time I don't think most of us would actually do that. I think we would just sort of deal with the ugliness of it all. So again, I'm going to change this bin width to 10. And I am going to put this left so they sort of match up. So you can sort of see I can get rid of one or the other, but they're right on top of each other, which is fine. And now I will put this box plot, and I put the other one at 15, so I don't know, I'll put this one at 20. So now you can see I can sort of compare the data to each other, and the box plots are fine. The histograms I can kind of make pop in and out, and I feel like that's a better use of my time than it is to screenshot all this and move it into another document. If you want to see what it looks like when I did that, you can again look at 10.1.3, but I don't really feel like it's worth doing that right now. So 1060A, make a combination histogram and a box plot for each sugar. Again, we did that in TI-84 and in Desmos. Pick whichever one you prefer. Now it says calculate the mean and median of both collections of data. There's a bunch of different ways to do this. Eventually I can show you how to do it in Desmos and in the calculator, but for now I'm going to use Excel. And essentially this uses what's known as formulas, and I don't know how good you guys are with this. You would think you would make the formula say mean. I'm sorry. Let me go backwards. First of all, I'm going to do sum. What that's going to do is just add all this up to make sure I have the correct sum. So this should add up to 760. Here's my sugar W. Excuse me, here's my sugar P. Again, this is just sort of my checksum here. So if I look back over here, they both have a checksum of 760, so they added up to 760. Now I want to calculate the mean and the median for both. So again, super easy. On this, you would think you would take equal mean, but it's actually equal average. So I'm just going to highlight that, and it's going to give me the average of those numbers. Here I'll do the same. So you can see the means are the same. The median actually is the median, so I'll go equal median, enter. So, wow, it has the same mean and median, and I'll bet you this ends up being 40 as well, and it does. So if we go back and look over here, you'll notice that the median's the same. It makes sense that the mean will be the same because they both average total 760, and we're dividing by how many numbers there are. So it makes sense that the mean and the median's the same. But I think the point the book is trying to make is that if you look at the data, they're not the same, right? This one has a little bit of everything spread out evenly, whereas this one is really kind of centered in the middle. But think about what we talked about. This kind of is like a normal distribution, and this is also a normal distribution. They just look remarkably different because one is spread out more than the other. Sorry, I have so many things open. I'm clicking around. Hope you guys are following this. So the two data sets are obviously not the same. Which statistic can be used to differentiate between the two data sets? Well, like we said, spread I think would be the way to go. It doesn't look like the central tendency is working, median and mean. So let's look at spread and see how they differ in this data. And that might kind of show how they're different, since mean and median are not showing that different. So it's saying you don't need to calculate the statistic yet, but we're going to get there. Anything like range, interquartile range, standard deviation, which again the book implies you guys know, but normally kids don't have that knowledge. So we're going to go over standard deviation today. And again, you're going to want to know standard deviation for the test. So make sure that you get something out of this video and reach out to me if you don't. So in problem 1060, you saw that in addition to knowing the typical value, it is also sometimes important to know something about the spread of the data, a set of data. So one way to measure the spread of data is to calculate the range. That's the maximum minus the minimum. So what are the range of each sugar? So let's go over here and let's get the range. Well, 70 minus 10 is 60. So here I'm going to have a range of 60. And here, I'm going to have this biggest is 70, the smallest is 10. I'm also going to have a range of 60. So, again, not terribly conclusive. So again, the range of both is 60. Another method for measuring the spread is the average distance to the mean. Now, we're going to calculate the mean absolute deviation, but I will tell you right now, it pales in comparison to the standard deviation. So we'll do this once and probably never do it again. So just sort of follow through how we calculate it and why we calculate it. But the standard deviation is going to be where we end up. So I don't want you to, if you're not really following the mean absolute deviation, it's fine, but you need to know the standard deviation. So another method for measuring the spread is the average distance to the mean, called the mean absolute deviation. So determine the distance each value is to the mean. Remember, we're going to use the absolute value, and I'll show you how we're going to do that, and this is one of the reasons why I wanted to use Excel. So we're going to basically say how far is everything to the middle, and then we'll get the average of that, and then find the mean distance. So compare the mean absolute deviation in sugar W to that of sugar P. So again, we're going to determine the distance to the mean, and we'll get that as an absolute value, then we'll get the average of that. So we're going to go here, and I'm going to say, all right, well, I know that the mean is 40, right? So I'm going to write a formula here. It's going to say, I want whatever this number is minus 40. So 10 minus 40 is negative 30. And then you can see kind of the nice thing is I can just copy this down. It's going to copy that formula. 32 minus 40 is negative 8, and so on and so forth. So I get all these numbers automatically filled in. But like we mentioned, we want the absolute value. These are not the absolute value. So we can write, this is pretty neat, absolute value. I just want, what's the absolute value of these numbers? So you can see it's going to change them all to the absolute values. And what we wanted was we wanted the average of these. So we're going to say equal average of these numbers ends up equaling 7.05. So that is going to be, so for sugar W, we're going to end up at 7.05 for the mean absolute deviation. So sugar W, ugh, so lazy, and I make things worse. So sugar W is going to be 7.05. Sugar P, we'll go back over here. Again, we'll write, we have a mean of 40 again, so we'll write our formula. We're going to say I want to take this and subtract 40. Then I will copy this down the whole way. Then I will say, well, I want the absolute value of that. So I would say this, if you're not familiar with Excel, it's a really good program to know. We used to teach it at the high school. I actually used to teach that class. They don't have it anymore, obviously, but I'm a big believer in knowing what these computers do beyond YouTube. So at this point, I get the equal average, and I get 16.3. So I can go fill that in. So for P, the mean absolute value, or the mean absolute deviation is 16.3. So really, what does that mean? Well, that means that a deviation is sort of like a level over. So these both have a mean of 40, right? This is what the average turns into. However, when I look at sugar W, it wouldn't surprise me if it moved as much as 7 in either direction. This is sugar W. However, sugar P, again, starts in 40. But now it wouldn't surprise me if it jumped as much as 16 in either direction. So, I don't know, for lack of a better term, sugar P is more erratic, right? Getting a 24 out of sugar P isn't surprising, but getting a 24 out of W is surprising. I guess if you think about it in terms of an athlete, this guy, maybe he's a basketball player, gets like 20 points every night. Sometimes it gets 18, sometimes it gets 22. This guy gets 20 points every night, but sometimes he doesn't score and sometimes he scores 40. He's just all over the board. So that's kind of like the mean absolute deviation and the standard deviation essentially are a way of saying how often are we normally close to the mean, right? Do we expect to be close to the mean? I know the average is the average, but how much will I sway by the average? Will I sway a little bit or will I sway a lot? And that's what the mean absolute deviation and the standard deviation are essentially calculating. So mean absolute deviation should not be calculated if the data has outliers. Well, here's why. Because if it has an outlier, we should use the median. And the mean absolute deviation, again, if data has an outlier, we should not use mean. Well, you calculate the mean absolute deviation using the mean. Well, if we already weren't using the mean, why would we use the mean absolute deviation, right? We would use the median. And if we use the median, then we should be using the interquartile range. So if you remember, the interquartile range is part of the box and whisker plots that we've already calculated. So let's jump over here and let's look at these box and whisker plots and let's see. So when I look at L, which is the first sugar, actually it would have made a lot of sense if I had named these by the sugar letters instead of L and M, but whatever. All right, so it looks like I have about 34 for quartile 1 and 45 for quartile 3. So I'm going to jump over here and I'm going to say W is going to be 45 minus 34, so I get an interquartile range of 11. When I go to P, I have a quartile 1 of 25 and a quartile 3 of 55. So I'm going to get 55 minus, I can't even remember. God, my brain is going. 55 minus 25 equals 30. So these are our interquartile ranges. And again, you can see, looking at this spread of measure, we expected P to have more variety. And looking at the interquartile range, we also expect P to have more variety. It jumps around more. The middle 50% takes a bigger range than the middle 50% here, right? The middle 50% in W doesn't go very far, but the middle 50% in P goes a lot further.